General angles and radian measure.
Okay.
Should I give you a problem?
Up until, yeah, do you have some problems?
Yeah.
Okay, go ahead. And it'll tell me what level you're at based on your problems.
All right, so these problems are rewriting each degree measure in radians and each radian measure in degrees.
All right, we can do a couple of those, and I'm sure you'll get the hang of it pretty quick.
Okay, cool. So the first one is 160 degrees.
Okay. Now, when you're converting one to the other, the conversion factor is pi over 180 or 180 over pi. And you're converting it to change it from degrees. So the conversion factor has to have the degrees in the bottom and the pi in the top. And this is pi radians, if you must. It's not actually a unit that is used very much. There's an odd thing about radians that we won't go into. But notice when I am converting this, the degrees cancel. And so what I end up with is 8/9 pi radians. Now, when you're going the other way, when you start with radians, then you use the opposite of that conversion factor. Because you're trying to get rid of the radians, you got to have degrees in the numerator. So it's got to be 180 degrees over pi radians. Now the radians cancel, pi's cancel, and you get 90 degrees.
Oh.
That's how you do it going either way.
Okay, cool.
Okay. So give me one and I'll have you do it and make sure you know how to do them. And then there's something else I want to add.
All right. 7 pi over 3.
So what are we going to multiply this by? What's the conversion factor?
It would be 180 degrees over pi.
Yeah, whatever you're trying to turn it into needs to go in the numerator.
Okay.
And we're trying to turn it into degrees. So what does this become?
That becomes 7 times 180 over 3, and that is that's 1260 over 3.
Notice the way I did it. I canceled the 3 out with the 180 first before I did the multiplication.
Oh yeah, that would make it.
Didn't need a calculator. You can do a lot of these things in your head or manually if you realize that 3 goes into 180 exactly 60 times.
Okay.
Okay. All right. You got another one going the other way? How about degrees to radians?
Yeah, negative 110 degrees.
Okay, the negative sign is just going to carry forth, so the only part you need to convert is the 110. So what's the conversion factor?
It would be times pi over 180.
It's always that. It's either pi over 180 or it's 180 over pi, depending on which way you're going. It's never anything different. Okay, so what's this going to be?
Negative 110 pi over 180.
And simplify that.
11 over 180, or 18.
Okay.
11 pi over 18.
11 pi over 18, yeah. And like I said, the negative sign just carries forth. Okay? Now, there's a few that you want to memorize. And let me show you a really easy way to memorize them. The most important ones are these that I'm writing in there right now. Okay? Now, that's equal 90 degrees. That's equal 60 degrees. That's equal 45 degrees. And that's equal 30 degrees. How did I do that so fast? Notice that the denominator on the left multiplies by the answer to give you 180.
Okay, cool.
Okay? And this makes it easier to do even harder ones. You're going to have things like, what is 2 pi over 3? What is that in degrees based on what's on the left? This is 1 pi over 3.
Would it be 120?
Yep. And what is 3 pi over 4? Another very common. These are also going to be angles that you have to deal with for a long time. So it's worth having a little shorter method to convert them rather than having to go through the pi over 180 all the time, or the 180 over pi.
Would that be 135?
Yeah.
Okay.
So it's helpful in these smaller angles. Not so much that when you have 7 pi over 3. There is one thing about that one. Let's talk about. That's greater than 360. Okay? And all trig functions of angles are based on multiples of 360 degrees. So you can always add or subtract 2 pi to that. Well, that's 6 pi over 3, so that's 13 pi over 3. In other words, all your trig functions of that are going to be exactly the same for that. It's not necessarily the same angle, but the trig functions are always the same. Now, normally what you want to do is you want to take these angles that are outside of the unit circle and you want to bring them in, so you subtract 2 pi, which gives you pi over 3. Now, that's a first quadrant angle. You had the unit circle, Jake?
Yeah.
Okay. It's just that you were always doing it in degrees, and now they're introducing you to radians.
Right, yeah.
Correct? Okay. There is a strange thing about radians. Doesn't convert to degrees in the same way that inches convert to centimeters, or gallons convert to liters. Not the same. Radians have to be used when you're doing calculus. You can't use degrees. So that's why you need radians. And calculus doesn't work on degrees, oddly enough. And a radian is defined as the measurement right there of that arc. When you have that being the radius, that would be 1 radian if this measurement was equal to the radius.
Okay.
Okay, that's the way radian is defined. It's a certain rotation. It's about 57 degrees, but it's a certain level of rotation. And it's a measurement that works with all circles regardless of their radius. I wish I could explain better to you why degrees do not work in calculus. But anyway, what else you got? Anything different than just converting?
No, I got that pretty much down
Yeah,
now.
I would think that, like I said, once you get them, a couple of them done, um, rest kind of fall into place.
Yeah. I have a little more of a problem with trig functions of any angle.
Okay, let's work on those.
Okay.
Give me some.
So it says to sketch the angle, then find the reference angle.
Okay.
So this one gives me negative 11 pi over 3.
Now, if I do this properly, that is 1 pi over 3 short of 4 pi. So I'm going to go around once. That's 2 pi. And now I have to add 5 pi over 3 to arrive right there. And that reference angle, or yeah, that's the reference angle, is pi over 3. Okay? Now, do you understand everything I did there?
Yeah.
Okay. Now, usually you don't have to do that. What you usually do with that is you find the coterminal angle that's inside the unit circle. Because we know how to deal with angles that are inside the unit circle. If they're in quadrant 1, you should have those memorized by now. If they're in quadrant 2, you can convert them to what they call the reference angle, is what I call the equivalent first quadrant angle. Notice. What else did they want you to do with this? Anything?
Uh, they wanted to find the reference angle.
And we found it. It's pi over 3.
Okay.
Okay, hold on. I want you to be clear on this because it isn't. To me, the reference angle is too complicated of a way to explain it. Let's take this 150-degree angle here. And I'll use degrees just because you're still probably a little more familiar with them. Well, what reference angle does that create?
Is that 30?
Because those two angles are supplementary. And I also have in quadrant 1, 2, 3, and 4, I have these equations for figuring out the reference angle. That's what that does. You took 180, you subtracted 150, our angle, and you got 30. So that turns out to have all the same trig values as a 30-degree angle would have.
Okay.
Now let's look at a 225-degree angle. Well, the reference angle is that theta, I'm not going to call it theta because it's not the same theta. Let's call it, can't call it anything when I got the eraser on. Let's call it beta. What is beta if that whole thing is 225?
45.
Okay, and you get that 45 by doing this. 225 minus 180 gives you that reference triangle or that reference angle. Same thing in the fourth quadrant. That's what they do. Okay, so rather than dealing with these reference triangles, and they'll, unless they give you a problem, and then you have to deal with them. So I guess you kind of have to understand them. But the quick and dirty method way of doing it is right here. And then over here, it's 360 minus theta. So just memorize those three. And if you're in radians, then what is it going to be instead of 180 minus theta?
Pi minus theta.
Yeah. And down here, it's going to be theta minus pi. And over here, it's going to be 2 pi minus theta. So whether
Okay.
you're dealing in radians, once you get used to dealing in radians, you'll want to stay using them. You don't want to go through the difficulty of converting to degrees, solving it in degrees, and then converting it back to radians.
Right.
You'll get used to the varying radian descriptions. And so what was the problem again?
It was -11 pi over 3.
We did that one. What do you got after that?
Oh,
That was the negative one. Now, negative, you know the difference between negative and positive.
yeah,
Negative just goes clockwise instead of counterclockwise.
right.
Okay.
These next problems say we have to evaluate the function without a calculator.
Good. Those are the good ones.
This one is cosine times -210 degrees.
Okay. First of all, that's not a times.
Okay.
Any more than when I say that's not f times x. That is f of x.
Okay.
When you take trig functions, you take trig functions of angles. So it's cosine of -210 degrees. And the way we're going to figure that out is I think I went through this with you last time. There's the hard way and there's the easy way. Let's use the easy way. What kind of function is cosine? Is it odd or even?
Odd.
It's even. Okay. In other words, if you look at the cosine curve, it is symmetrical about the y-axis, and that makes it even. And there is an aspect about evens, which is that the cosine of a minus angle is the same as the cosine of that angle, the positive angle. So we've eliminated the minus sign in one step, which is a good thing. Minus signs give everybody a lot of trouble. Okay? Just remember cosine is even, sine is odd, and tangent is odd.
Okay.
So, what's the next step? What quadrant are we dealing in? I just realized I got a major. Let's figure it out as if the question is, what is the cosine of 210 degrees? That will be legitimate. Let me draw 200. What quadrant is 210 in?
Quadrant 3.
Okay. What is its reference angle?
30.
Which I write like this. That's also what I call the equivalent first quadrant angle. And now you should have the cosine of 30 memorized. What is it?
I'm not sure.
It's root 3 over 2. There's only a couple of answers to these questions. There's 1/2, there's root 3 over 2, there's root 2 over 2, and there's 1 over root 3 or root 3 over 3. Those answer all your first quadrant trig functions, pretty much.
Okay.
Now, I got to put a plus minus sign on there. What is it? All students take calculus. Always go counterclockwise. Go the same direction as you go when you label the quadrants.
Counterclockwise, so it's positive.
We're in the third quadrant, right?
Yeah.
What's positive in the third quadrant?
Tangent.
Everything else is negative. Except tangent's reciprocal, cotangent, is also positive, but only tangent and cotangent. That means
Okay.
sine and cosine are both negative. So we need a negative sign out there. Now, that's our answer, and you might ask yourself, well, isn't this actually in the second quadrant? Which it is. But notice it gives you the same reference angle, 30 degrees, and it gives you the same answer, negative root 3 over 2, because cosine is negative in that second quadrant. So we got it correct in the shortest amount of steps.
Okay.
And the long way would have been to find the coterminal angle of cosine of 230. Let me just make sure you're aware of this difference. So I would have said, okay, well, the first thing is that that's the same as 170, a positive 1, hold on a second, 150. Okay? In other words, if I was bothered by the negative sign and I didn't remember that it was an even function, well, I'm going to do it the hard way. First thing I'm going to do is turn it into a positive angle inside the unit circle. Well, I do that by adding multiples of 360 until I get an angle inside 360. First one I got was 150. Now, figure out that. Was that equivalent? What's that reference?
30.
Cosine of 30 again is root 3 over 2. And because we're in the second quadrant, we are negative. So we get exactly the same answer. And for this problem, the same number of steps. Quite honestly, and if it's a fourth quadrant angle, it's much quicker. It's 2 steps quicker the way I do it. If it's a second or third quadrant angle, it's really the same. There's not that much. I guess maybe I had to do, no, I took 1 step to convert that to that. But I actually took 1 step to convert that to that also. I had to know that it was an even one. All right,
Okay.
let's do some more of these because these are really valuable and you really need to get good at these. If you had flashcards for anything, it would be these. Although you don't really need flashcards because you can figure it out. As long as you memorize the unit circle, you can figure it out. You don't need to memorize all 16 points on the unit circle. You just need to memorize those 2 triangles and this picture that's in front of you.
Okay.
So give me another one.
Tangent of 210.
Okay, I'm over here in the upper right in case you can't see.
All right.
All right, and then I put parentheses. Let's work with its reference angle.
Would it be 30?
Yep. First you identify what quadrant it's in. Third. And that tells you use this formula.
Okay.
Now what's the tangent of 30?
That would be
You need to memorize these. You can't get it off your calculator. Your calculator's not going to give it to you in radical format. These 2 triangles will always give you the reference angles that they expect you to know by heart. They don't expect you to know what the cosine of 29 degrees is, but they expect you to know what the cosine of 30 degrees is. And the way you memorize it is you memorize the dimensions. So what's the tangent of 30 degrees?
Oh, is it 1/2?
SOHCAHTOA. You got to memorize that also. There. Everything
Oh,
that's on the page right now, you should take a picture of.
okay.
And make a note that you got to memorize it. Now, I got a lot of stuff on there that you don't need to memorize, like these red circles in the middle. But these two triangles, SOHCAHTOA, ASTC, and these formulas that I have circled in the various quadrants. Just
Right, okay.
memorize everything that you see there, and you'll be able to figure out all of these.
Okay. Is it 1 over the square root of 3?
Yes. Now,
Okay.
your teacher may let you get away with that. He's accepting irrational answers.
Yeah.
Okay, good. That's better. Yeah. Okay, we got time for another one. Here, let me erase some of this stuff. If you want, let me erase a lot of it, and you can just pull your camera out and take a picture of it.
I got a picture.
Okay. Problem is it had all this other junk that you didn't really need in your picture. But, okay, what else?
Let's see.
Over here in the upper left.
Sine of 225.
You work me through the rest of it.
Okay. Let's see. The reference angle's 45. And sine of 45 would be 1 over the square root of 2.
Okay.
Negative 1 over the square root of 2.
Well, we put our plus and minus sign on as the very last step.
Okay.
So what quadrant am I in?
Third quadrant.
Which sign is positive or negative?
It's negative.
That's when we put the sign on right there. That way you don't have to deal with it until the very, very end.
Okay.
Okay? You just got to know what quadrant you're in.
All right, sweet.
Let's do one more. And this is something you need to practice this. You need to not only be able to do it, but you need to be able to do it a little bit faster.
Okay.
Okay? Go ahead. Give me another one.
This one is secant of 9 pi over 4.
Inside or outside the unit circle? The unit circle is 2 pi. Is that number bigger than 2 pi or less than 2 pi?
It is bigger than 2 pi.
Okay, so it's outside the unit circle. So what are we going to do first?
We find the reference angle?
No, got to subtract 2 pi. Because it's outside the unit circle, we can find its unit circle angle by subtracting 2 pi. And
Okay.
pi in this case is 8 pi over 4, right? I got to have a common denominator. So this question really is, what is the secant of pi over 4? What is the secant the reciprocal of?
Cosine.
Hold on a second, I'm not writing this correctly. It's the secant of pi over 4. So it's 1 over the cosine of pi over 4. There's two ways you can do it. Tell me what the cosine of pi over 4 is.
$45.
Good. What's the cosine of 45 degrees?
Is it square root of 2 over 2?
Well, that's another way of saying 1 over square root of 2.
Okay.
In this case, 1 over square root of 2 works a lot better, as you're about to discover.
Okay.
Because if I do square root of 2 over 2, now what would the secant be? It would be the flip of that, 2 over root 2. And if I have to rationalize that again, I got to do 2 rationalizations instead of none. Because here, if you look at this triangle over here on the right, it's the cosine is 1 over root 2. Well, the secant is root 2 over 1. Simple as that. It's always the hypotenuse over that side.
Okay.
Rather than thinking about it algebraically, which we would have had this, that's what we would have been solving. That solves to root 2 over 1. But you can see it graphically easier in that triangle by just flipping the two. That's what those mean.
Okay.
Okay? All right. Jake, I'll talk to you next Monday.
All right. Thank you.